All right, welcome to the night class. Today we're going to do 3.5, which is continuity and in behavior. Continuity. Any of y'all happen to know what continuity means? Continuity means it continues. Continuity is, okay, it's a, continue is a root word, so basically it has continuity if you can draw it, if you can draw the graph and not pick up your pen to draw it. Okay, if you can draw one big fluid line or curve or whatever you're drawing, if you can draw it and not pick up your pen, it's continuous. If you have to pick up your pen, it is considered to be discontinuous. Okay, if you have to pick up your pen, sorry, that would be discontinuous. So, and there's three types of discontinuity that they talk about. The first one is infinite discontinuity. The second one is jump discontinuity. And then you have point discontinuity. So, infinite discontinuity, there are these things in math called asymptotes. Okay? And what they are, this is an example. This first one right here that I'm pointing at, it has two asymptotes. Okay? One asymptote is the y-axis, excuse me. It's the y-axis itself, okay? So, when you have a graph like this, these blue lines, they are going to continue to get closer and closer and closer and closer and closer to the y-axis, but they don't ever actually get there, okay? Let's talk about y. What is x on the y-axis? 0. And here's your function right here, right? F of x. I'll write it bigger so you can see. 1 over x squared. So if x was 0, what would we be dividing by? 0. And you can't divide by 0. It's undefined. So that's why it doesn't ever actually get to 0, because it can't. Okay? As soon as you get to 0, it's undefined and you have to quit. All right? But you can just keep getting closer and closer and closer to 0. That's the great thing about numbers. Okay? You can always get closer without going the entire way. Okay? Now, I realize in physical world that's not true, because eventually you get so close that you can't even move, okay? Because it's so small the distance you're going, okay? But with math, it can be 0.00001, or we can get closer to 0 and say 0.000000001, or we can just keep adding zeros and we'll get closer and closer to 0. Is that making sense? Okay. Same thing on the other side. So this is called, this line that it's approaching is called its asymptote, okay? There's another one going right here, the x-axis. It's never going to cross that line either, all right? This is how they are spelled, asymptote, okay? For jump discontinuity, you've seen these before. You've seen these like they kind of combine two graphs together, okay? When x is less than 0, you're going to do x squared plus 1. But if x is greater than 0, you're going to do x. Okay? So 1 starts here and goes, and then it jumps down, and then you start a new graph. Okay? That's called jump discontinuity. And the other one is point discontinuity. And basically, it's continuous everywhere except for just one point. Okay? Just one. It's right there. It has a little hole in the graph. Now, where is the hole? What point is that? Can y'all see it? -1. What? -2. It's -1, -2. Okay? X is -1. Why would we have a hole at x is -1? Think back to the first example.
It can't be.
Here's, if it's x squared minus, I'll put plus, it doesn't matter, over x plus 1, if it's -1, what are we going to have on the bottom? 0. If you plug in -1, you're going to have 0 on the bottom, and we can't divide by 0. Okay? So there's a hole there. All right? So why, and again, I'm getting a little ahead of ourselves, but why do we have just a hole and not an asymptote? Because over here we had an asymptote. Over here we have a hole. Here's why. I can factor this top part out, okay? That'd be x plus 1 and x minus 1. And we still got x plus 1 on the bottom. And now the x plus 1s can what? Cancel. That's why there's just a hole rather than an asymptote. If it couldn't have canceled, we would have had an asymptote. Okay? Now, the great thing about it is you're not going to have to do much as far as this today. Okay? All they're asking you today is it continuous? All right? And then we're going to talk about the end behavior of graphs. So, let's worry about the continuous part first. To be continuous, there is 3 tests you have to go through, and you have to do them in this order, okay? And a lot of this, if any of you have aspirations of taking calculus, you'll talk about things being continuous in calculus a lot, okay? So, here's the rules. 1, the function is defined at c. In other words, f of c exists. And I realize you may not understand this math gibberish, but I'll explain it in just a second, okay? Number 2, the function approaches the same y value on the left and right sides of x equals c. And number 3, the value that the function approaches from each side is f of c. So, all that's like, what in the world is he talking about? Let me try to explain it for you, okay? Now, it's already here in your book. I am going to, I'm going to see if I can erase this and show you my way, okay? Is it really going to take me this long? Oh, goodness. All right, I'll just come over here on the other side, right? All right, so step 1. Find f of c. Does it exist? Okay, so what are we testing if it's continuous at? We're trying x equals 1. They want to know, is it continuous at x equals 1? Okay, so understand, they're not asking is the whole thing continuous. They just want to know at x equals 1, is it continuous? Okay, so the first thing you figure out is you plug in 1. Okay, f of 1. What does f of 1 give me? 3 times 1 squared plus 7. What does that give me? Do I get an answer? What is it?
10.
10. 1 squared is 1, times 3 is 3, plus 7 is 10. Everybody with me so far? It passed test 1. Okay? If we plug it in and we get undefined, we can stop right now. It's not continuous. Okay? As long as you get an answer when you plug it in, you can keep going. All right? Test 2. We're going to test points from either side of 1 and see if they approach the same number. Okay? So, we're going to make 2 tables. All right? On one table, we are going to approach 1 from the left, and on the other table, we're going to approach 1 from the right. Now, understand, we want to get very, very close to 1. Okay? So, what's a number on the left of 1 that's really, really close to 1? Point what? 0.9. Not that close. We're going to start with 0.9. Okay? What's a little closer?
0.99.
0.99, and a little closer than that?
0.999.
0.999. All right? On the other one, we're going to approach 1 from the other side. Okay, so now we're coming from 1 from the right side. So what's really close to 1 on the right side?
1.9.
1.1. 1 point what? Not 1.1, but what? 0.1. And then even closer would be 1.001. That making sense? Okay? Now that I've showed you this, I'm going to use the books. See how they used it right here? Now you take these numbers and you plug them in to your equation, just like you plugged in 1. Okay? So apparently when you plug in 0.9, you get
9.43.
9.43. When you plug in 0.99, you get 9.9403. And when you plug in 0.999, you get 9.994003. Everybody seeing that? Okay? On the other side, when you plug in 1.1, you get 10.63. Okay? When you plug in 1.01, 10.0603. And when you plug in 1.001, you get 10.006003. All right? So, to pass test 2, both of these have to be approaching the same number. Okay? What do I mean when I say approaching? I mean, are they getting closer and closer to the same number? What is this getting closer and closer to? 10. 10. It's getting closer and closer to 10. What's this one getting closer and closer to? 10. That passes test 2. They are approaching the same number, okay? Test 3 is actually very easy to do. Is the same number they approached the number we got in test 1? Yes. So this is continuous. This one is continuous because it passed all the tests, all 3 tests.
So if it didn't
Okay.
pass one of the tests, would it make
It's not, it's discontinuous. That's all you got to put. Okay? If it as soon as you get one that it doesn't pass, you can stop. Everybody got me? Okay? So 3 things. Like I said, the last 2, really, once you do the second step or second test, you're doing test 2 and 3 at once, basically. Okay? So test 2 is they have to approach the same number. And then test 3 is that number the same thing you got in test 1? Everybody with me? Okay? Let's try another. No. All right? So here, I'm just going to go with what they have here. We're testing 2, right? So the first test, I'm going to plug in f of 2. Well, if I plug in f of 2, that's 2 minus 2 on top is what? 0, which is fine to get. But on the bottom, I get 0. Can I divide by 0?
No, sir.
No. So this is not continuous.
Will you scroll back up?
Sure will. All the way? Or is that good?
That's good. I was just.
Okay.
So what would your answer be for that one? Just.
It is continuous.
Yes, sir.
All you're putting it is continuous or not continuous.
Yes,
And
sir.
showing me your work, how you figuring that out.
Yes, sir.
Okay? So on part B, as soon as I plug it in, I'm getting undefined. It's not continuous. It doesn't pass the first test.
Yes, sir.
All right? C. One of these where you got 2 and 1, right? Okay? So, is it defined at 1? So I plug in f of 1. Here's 1, right? I'm plugging it in. Which one do I plug it into? The top one or the bottom one? Not both.
the bottom one?
The bottom one, because this is where x is what? Equal to 1. All right? So x is equal to 1. I use x. So f of 1 is just 1. Because it says it's equal to x. So did that pass? Is that okay? Can I get 1? Yes. All right? Now we do either side of 1. And understand we're doing 1 twice, which I hate doing the same example. If it was 2, here I wouldn't put 0.9, I'd put what? 1.9. 1.99. 1.999. Okay, and that'd get 2.1, 2.01. All right, so understand it depends on where you're trying to check. Okay, if you're checking 1, you're going to use these numbers. As you can see, we plugged them in. This one gets 0.9, 0.99, 0.999. So what is it approaching?
2. I mean 1.
1. Over here, what's it approaching? It's also approaching 1, correct? Okay, so did that pass test 2? Yes? Are both of those, are what they approaching, equal to what we got in test 1? Yes. So it is continuous. Okay? It is continuous at 1. Any questions? Everybody good on that? Not too bad? All right. The next part that we're going to talk about is describe the end behavior. Okay? Now, they have a big table here. I'm not going to make you do that. Okay? You don't need it. All right? End behavior. What is the graph doing at the ends is what this means. Okay? You know how you have a graph, right? Now, you very rarely draw the ends because you can't, right? Because all the graphs continue on for how long? Forever, okay? But say we'll just do a quadratic. You draw something like that, and you draw it, and the arrows mean they're telling you that it's what? It's going forever, okay? So, what's happening on the ends? As x gets smaller, as x goes to negative infinity, right? What's the y doing? It's going where?
Increase.
Increasing. So where is it going if it's increasing? To positive infinity. Okay? As x goes to positive infinity, what's y doing? It's also going to positive infinity. Okay? So that's all you're doing here. You're going to put as x approaches infinity, what's f of x doing? And as x approaches negative infinity, what's f of x doing?
Didn't we already do this one?
You may have done it in Algebra 2. I'm not really sure. All right? So, here, they make this big, long table. Okay? I'm going to make it way easier. All right? Sometimes we make math harder than it needs to be. Okay? So, f of x equals negative 2x to the third. All right. Everybody listen. Everybody with me. Okay? This one, they start us off pretty easy. If I were to plug in infinity, I would get that, correct? Everybody with me so far? What is infinity cubed? It's still infinity. What's infinity times negative 2? Negative infinity. I would get negative infinity. Does that make sense?
Yes, sir.
Okay. What if I plug in negative infinity? Negative infinity cubed is negative. Remember, negative to an odd power stays negative, right? So we have negative infinity times negative 2 will be positive infinity. And so here's the answer. Here's how you write your answer. As x approaches, you just use a little arrow. As x is approaching negative infinity, what was f of x approaching? Positive. No, yeah, positive infinity. Okay? As x approaches positive infinity, f of x will approach negative infinity. Okay? This part right here of your answer, it is the same thing every time. You will write that down every time. The only thing that changes is what f of x approaches. Does everybody understand that?
Which one?
Ma'am?
Which one goes with which one?
Well, see where I plugged in negative infinity? That's as x is approaching negative infinity.
Okay.
Okay? Everybody with me? All right. Now, a few little tricks. Okay? If your highest degree that you're looking at is odd, see how it's 3? You will never have down here, that will never be approaching the same. If one's approaching positive infinity, the other one's going to be approaching negative infinity. Everybody with me?
Yes,
They will always be opposites. If it's an even number, they're both going to be the same. If one's approaching positive infinity, the other one will be approaching positive infinity. If one's approaching negative infinity, the other one will be approaching negative infinity. Okay? Everybody with me so far? All right. This second part, g of x, I'm going to change it. Okay? Just because I want to show you what I'm talking about here. I should have left that what's not going to change, but oh well. I'm going to say negative 2x to the 6th minus 3x to the 5th plus 6x squared. Okay? Which power, and I know this is going to be a little confusing, but it doesn't have to be. Which power is making it what it is? What do we always look at? When we're deciding what family it belongs to, what do we always look at? Which power? The biggest. Now, normally when it's in standard form, it's the first one, okay? This overall is telling you right here, this 6. It's the one that's telling you, hey, this is what type of equation it is, okay? This is also the one that tells you the end behavior. Because it really doesn't matter what these other two are, 5 or 2, okay? If I'm taking something to the 6th power or taking the same number to the 5th power, which one's going to get bigger faster? The 6th. Or if it's negative, which one's going to get smaller faster? The 6th. See what I'm saying? Okay? So these, when you start plugging in really big numbers, because remember, we're going to infinities, right? Okay? So when you plug in a really big number, these start not to matter. Okay? The 5 and the 2, it doesn't really matter what they are because the 6 takes over. You got me? All right. So all of this behind it, you don't really need it. You just ignore it. Okay? And all you're worried about is if I plug in negative infinity for x, okay? Again, am I putting all the rest of that behind it? No, I'm just doing the biggest. Okay? If I plug in negative infinity to the 6th power, it becomes what? Positive infinity times negative 2 would be negative infinity. And if I plug in positive infinity, what is positive infinity to the 6th?
Positive.
It's still positive infinity, right? Times negative 2, so I get negative infinity. See how they go to the same thing? Why is that happening? Because my exponent is what? Even. Okay? If it's odd, if one's going to positive infinity, one will be going to the negative infinity, or vice versa. Okay? So, as x approaches negative infinity, f of x approaches negative infinity as well. As x approaches positive infinity, f of x will be approaching negative infinity too. Okay? And you can even get a little more complicated or simple, as however you think about it. Why do you think they're going to negative infinity? What's making them do that? The negative in the front. Remember, I'm taking it back to just normal. When it's a quadratic, how do you know when the u goes down? When there's a what out front?
Negative.
A negative. Okay? On your slopes, right? When it's just a y equals x. Y equals x. My slope is going to be what? Positive, right?
Yes, sir.
Okay? Well, what would make it go the other direction?
If you had a negative.
If you had a negative. So that's the same thing. If it's a cube, we talked about cubed earlier, all right? Cubes look like that, right? Notice their overall track is going where? Up, all right? Well, if you did a negative x cubed, guess what? The overall track is going to be going down. I'm not worried about what's happening in the middle. I only care about what's happening where? On the ends, okay? So really, you can always tell just by looking at what's the exponent and what's in front of it, okay? Y'all have a great day.
You took us.
Stay above the line.